Here we will find the volume and total surface area of a rectangular base octahedron. Let us find the total surface area and volume of the rectangular base octahedron. That means here the base, this shaded base, is rectangular and it's octahedron because on the top pyramid, since there are 4 arms here, so 4 side faces are here and 4 side faces in the bottom. So altogether 4 plus 4, 8 faces are exposed outside, so it's an octahedron. And to calculate the total surface area of this octahedron, this base area is not exposed, so we will not consider that. So we will just calculate these top 4 faces and bottom 4 faces, that is all side faces, that is total 8 faces, to calculate the total surface area. Now here another thing is, this base is a rectangle, so it's not a regular polygon. So we will be calculating each of the face on its own individual merits. So how we can calculate the area of one face? Area of one face is half times its arm length times its slant length. So we will be needing to calculate this slant lengths because the arm lengths are given. This rectangle's one arm length is 60, so this is another one is also 60, and this is 30, so this will also be 30. So let us name this octahedron as O, A, this is B, this is C, and this is D. And so let us name this as this base center is as X, and say let us give this name as P. So we got one pyramid at the top, another pyramid at the bottom, and base is same, but the top pyramid height is given 40 centimeter, but the bottom pyramid height is given 32 centimeter. So now these two pyramids are different. We need to calculate this 4 surface area differently, considering this as the pyramid, and this 4 surface area differently, considering this bottom as the individual pyramid. So let us start. Now here height is given. To calculate any face area, we need the slant length, and here it's a rectangle, so this BC and AD, these two arms are same, so their slant length will also be same. So let us consider this slant length as L1, and AB and CD, these two arms are same, so slant length on those two will be same, so this slant length we consider L2, and OBC, this face, and OAD, this face, these two faces area will be same, and OAB, that is the face on AB arm and face on CD arm, OCD, their area will also be same. So now So now we need to calculate this L1 and L2, these two slant length, to calculate the 4 faces area of this top pyramid. So to calculate this L1, we will use this OX and this triangle. So if we draw that triangle separately, so this is the slant length L, this is this length will be half of this AB length, because center to this arm, if we extend it total arm, so this will be the total length AB, which is 60 centimeter, so this will be the half, so this length is 30 centimeter. So this length is 30 centimeter, this is the slant length, and this is the height of this top pyramid, which is 40 centimeter. So this is 40 centimeter. So from here, this is right angle, we can find this L1. This slant length is L1. So if we use Pythagoras theorem, we will get L1 square equals 40 square plus 30 square, and if we do the calculation from here, we will get L1 equals 50 centimeter. So this slant length we found 50 centimeter. Now let us calculate this slant length L2. So L2, for calculating L2, we will use this triangle. this one, and this one. Now this height, this is perpendicular, and this distance, if we extend all the way, it will be equal to BC. So this is half of BC. So if we draw another right angle triangle, so this angle is right angle, this is the hypotenuse, is the slant length L2, this slant length we consider L2, and this distance is half of BC, which is 30 centimeter. So this distance is 15 centimeter, half of BC, and this height is 40. So if we use Pythagoras theorem here, we will get L2 square equals 40 square plus 15 square. So from here we will get L2. If we do the calculation, we will get L2 as 42.72. 42.72 centimeter. So we got our these two L1 and L2, these two slant length. So now we will calculate the face as half times arm length times slant length for this OBC and OAD together. So area of OBC or OAD will be half of its arm length. So OBC, its arm length is BC or AD, which is 30, and slant length is L1, which we got 50. So it is half times 30 times 50 for one of them. So we will get, if we calculate this, then we will get 15, so 750 centimeter square. And similarly, if we calculate the other one, OAB, that is face on this arm, OAB or OCD, they are equal. So OAB or area for OCD, which will be half times its arm length is 60 and slant length we got 42.72. So 60 times 42.72. If we do the calculation, we will get 42.72 times 60 and half is 30. We will get 1281.6. 1281.6 centimeter square. So therefore the total area, because OBC and OAD, they are equal, OAB and OCD, these two faces are equal. So altogether the four faces of top pyramid, if we consider the total surface area as A1, then the A1 will be twice of this, 2 times 750 plus twice of this, which is this. If we do this calculation, altogether we will get 4063.2 centimeter square. So this is one surface area for this top pyramid. We will do the same calculation for this bottom pyramid, but here the height will be 32, and this slant length, if we consider this slant length as L3, and this, that is on BC, and this slant length from P, this pyramid to AB, as L4. So we will do the same approach. This PX and this part of the distance is half of AB, that is 30. This height is 32. We can find this L2. So we will take this triangle PX and this point, this triangle. So if we take that triangle, this is our P, this is our slant length L3. So this height X is given, this height is given 32, and this length is half of this AB, which is 30. So this is 32 centimeter and this is 30 centimeter. From here, this is right angle, we can find this slant length L3. So L3 square equals this square plus this square, so 32 square plus 30 square. From here, if we do calculate, we will get L3 equals this slant length L3, we will get as 43.86 43.86 centimeter. Similarly, if we use on this AB line, this is the slant length. So if we use this triangle, this triangle. Here this angle is right angle because this is the height on the base, so this is right angle. And this distance is half of BC, that means half of AD, which is 15, and this distance is height. So we have a small triangle here where one side is 15, height is 32, and this is the slant length L4, which is this is the right angle, so this is the hypotenuse. So if we draw a small triangle like this, so this is the right angle, this is the height 32, and this is 15, so we need to find this L4. So here this is the height 32, this arm is half of this, which is 30, that means half of it is 15, so this is 15, this is 32, and this is the height, so this is angle is the 90-degree angle, right angle, so we need to find this hypotenuse L4, which is the slant length. So from here we will find L4 square equals 15 square plus 32 square. So 15 square plus 32 square, if we calculate from here, we will get the slant length L4 as 35.34 centimeter. So now we have these two slant length. So here this face PBC, this face, and PAD, these two faces will be similar because BC and AD is same, and PAB and PCD, these two faces will be same. So if we calculate them, then the total we will be doing at the same time, that here this surface is half, this area is BC, which is 30, and L3, and this area is half, this arm length is 60, and this slant length is L4. So if we calculate, then we will get triangle PBC equals triangle P, let us see, PBC and PAD, they are same, so PAD equals half of the arm length is 30, and slant length is L3, which is 43.86, because here the arm length is BC, which is 30 centimeter, and the slant length is L3, that we found 43.86. If we do this calculation, we will get 43.86 times 15, which will be 657.9. So 657.9 centimeter square. Similarly, triangle PAB or triangle, let's see, triangle PAB and triangle PCD, they are same, and their arm length is 60 and their slant length is L4. So triangle PCD equals half, their arm length is 60 and their slant length is L4, which is 35.34. If we do this calculation, we will get 35.34 times 30 is 160.2 centimeter square. Now we individually got this face PBC and PAD and PAB and PCD. Now we need to calculate the total four faces surface area. So if we consider this four faces surface area as total surface area as A2, then we will find A2 equals 2 of them, that is this 2 times 659.7 plus 2 of this, that is 2 times this, 2 times 1060.2. If we do this calculation, this surface area will be 3430.8 centimeter square. So now we got the bottom pyramid's four faces area, this bottom pyramid's four faces area, and this top pyramid's four faces area, top pyramid's four faces area. If we sum them up, we will get the total area. We will get the total surface area A equals A1 plus A2. So this is the total surface area for this octahedron, which we will get 9294 centimeter square. So now we got the surface area. Now we will calculate the volume. Let us see. Volume is easy. this is a rectangle. So base area, for volume calculation we need base area and height. So this base area will be, this side is 60, this side is 30. So 60 by 30, 60 times 30 will be the base area. And for this top pyramid, height is given 40 centimeter. And for this bottom pyramid, height is given 32 centimeter. So if we consider this top pyramid's volume is V1 and bottom pyramid's volume is V2, then the base area is 60 times 30. So that is common for both the pyramid. So the base area is 60 times 30, that is 1800 centimeter square. So the volume of the top pyramid is 1/3 times this base area, which is 1800, times the height. The height of the top pyramid is given 40 centimeter and the bottom pyramid is 32 centimeter. So top pyramid is 40. So this will be the height, this will be the volume for top pyramid. If we calculate it, we will get 24,000 centimeter cube. And the volume for bottom pyramid will be 1/3. Base area is same because common base, times its height is 32. If we calculate it, we will get 192,000 centimeter cube. So the total volume of the octahedron will be V1 plus V2. If we sum them up, we will get 432,000 centimeter cube. Now it's a big number. If we want to convert into meter cube, we know 100 centimeter equals 1 meter. So we will be getting 432,000 division is a centimeter cube. So it will be divided by 100 cube. That is 100 times 100 times 100. So this 20 gone, 1 2 3 4 0. So 1 2 3 4. So it will be 0.0432 meter cube. So its calculation looks complex and big, but basically what we did here is we handled two individual pyramids one by another. That's it. So that's how we calculated the total surface area and volume.